right. This is the last two sections. These are the last two sections of chapter 6, unit 6. It's going to do with solving exponents and log functions. 6.5 is exponential equations, and 6.6 will be log equations. So we'll see how that works. Everything now is going to be put together. When the bases can't be made the same, you're going to take the log or ln of both sides to solve the exponential. So prior to starting here, we had 6.3, I believe. What was it? Here it is. Yeah, we did this one, where you had the bases the same, and then they canceled, and you were left with the exponents. Here, you can't do that. Okay, so let's see how that works. They're kind of odd, but they work very well and very easily. Okay, so if you look at the first one, 2 to the x equals 3. I cannot make 2 into a base of 3, and I cannot make 3 into a base of 2. So what you do is you're going to basically use your powers, not your powers, your properties of logs. That property that says, and I will show you again. Okay, I need something here to be able to bring it down, because I'm solving for this. As you notice, my variable is in the power. The only way I can legally bring it down is if there's a log or an ln here. If there was nothing here, I could not bring this power down, because a to the r does not mean the same thing as r times a. Okay, so in order for me to bring it down, I need a log or an ln. If I don't have it, I can put it, but you just have to do it to both sides. So I can take the log of each of the bases. Once I have log of something to the something, this x can come down. Log of 2, log of 3, they are just numbers. They're ugly numbers, but they're still numbers. So when I do this, that's my answer. X equals the log of 3 over the log of 2. Do not try to be fancy and try to cancel the logs and say it's 3 over 2. Incorrect. Do not try to simplify it and say that's the log of 3 over 2. Also incorrect. It is literally the log of 3 over the log of 2. All those three scenarios give you different answers. So please don't make up your own. Don't make up your own theorems. Unless you're a mathematician, then you can make up your own theorems and you have to have proved it. So please don't make up any new rules. I'd rather you leave it like that. Okay? All right. Let's try another one. I just lost it. Let me go back to my pages. Okay, this will be a little bit more difficult, but it's still doable. 3 to the 2x minus 1 equals 5 to the 4 minus x. Okay, I'm trying to solve for variables that are in the power. I need to bring them down. In order for me to bring them down, I need to take logs of both sides. So I'm going to rewrite it because I left no space whatsoever. And that's going to allow me to bring these down to the left of the log. So here we go. 2x minus 1 log of 3, 4 minus x log of 5. Okay, like I said earlier, logs of a number are literally just a number. They're a crappy decimal, but they're still a number. So how do I solve for x? Well, I need to get them out of the parentheses. And I do not want to divide because that's illegal. I have parentheses that I have to deal with. So you need to distribute them. Okay, it's going to be a mess, but it'll work out. So this will be 2x log of 3 minus 1 log of 3 equals 4 log of 5 minus x log of 5. Next step is to find all the pieces that have an X. That would be this one. And that would be this one. Notice the equal sign in the middle. So your job is to move the pieces with the X's to one side and the pieces with just numbers to the right. So I'm going to add a 1 log 3. I actually don't need that one. That looks really confusing. And also, please do not attempt to add any logs. Just leave them alone. So that's 2x log of 3. This goes away. Equals 4 log 5 plus log of 3. I didn't put the 1. That looks really weird. Minus x log of 5. So now I'm going to add it. Plus x log of 5 plus x log of 5. Again, do not add. Do not make up your own rules. So this is 2x log of 3 plus x log of 5 equals 4 log of 5 plus log of 3. Like I said, this is a lot of algebra. I didn't lie. Now that you have both pieces on the left side, you're going to factor out an x because you cannot put them together. So you take out an x, and that gives you 2 log of 3 plus log of 5. This is just a big crappy number. 4 log of 5 plus log of 3. And then you just divide both sides by that crappy thing. 2 log of 3 plus log of 5. 2 log of 3 plus log of 5. Done. My answer is x equals 4 log of 5 plus log of 3. I should have left more space. 2 log of 3 plus log of 5. All of that is my answer. I don't need you to put it in the calculator. That is good with me. If they ask you to put that in the calculator, you can definitely make sure that you was on pen. You put all of this in parentheses. You hit the division button, and then you put all of this in the denominator. Okay? You can totally do that. Just type it in literally as you see it. Okay. I don't know why I squeezed that all in one part. I'm not sure why I did that. I normally don't write up down. Anyway. Okay, this last one, no, there's another one. Negative 3x equals 7. Okay, so you could take the log of both sides, but you'll have more stuff. You can take the ln. I'm going to take the ln because ln and e go away. They cancel, and you'll see that from the media, so make sure you check out the videos. So I'm going to rewrite it. And so I'm going to take the ln. This still comes down. Negative 3x ln e equals ln of 7. But this is 1. So I only technically have negative 3x equals ln of 7. See how it makes the equation so much easier? And all I have to do is divide by negative 3. Whatever that is, I don't care. Had you taken the log of both sides, then that log of e would be stuck there. So when you divide, you'd have to divide by negative 3 log of e on both sides. So you'd have log of 7 over negative 3 log of e. You'd have to have all of that written out versus this. Okay. So now you can do D. D is similar to this one, but a little bit less hectic. Okay. All right. We are on the last part, which is log functions, log equations. Okay. Log equations. All right. You should take a screenshot of this, take a copy of that. You will be using it on your exam. So please make a note of it. we have solving of equations broken down into 3 parts. Case 1, if you have a single log of something equal to a single log of something else, you can cancel the logs and make it equal to each other, make the arguments equal to each other. This is very similar to what we had in the exponent piece. Case 2 is where you have only one single log on one side. This is where you run the circle through and you end up with an exponential form. The last one is when you have 2 logs on one side and 1 log on the other. Do not cancel, cancel, cancel. That's illegal, okay? So what you would do is if you end up having 2 logs on one side, you want to condense. And if you condense and you end up with 1 log on the left and 1 log on the right, that brings you back to case 1. If you condense, because you have 2 logs, whether you add or subtract, if you condense on one side, but you don't have a log on the other, then you end up with case 2. Okay, these are my notes. At the very end, make sure you check your solutions. You should not have logs of negative numbers. Not that your answers should be negative. You can have negative answers, but just make sure that those negative answers don't come back and give you negatives in here, right next to the logs. Okay, so let's start with this one. These are actually not too bad. We'll be done with this pretty quickly. Right, we have log of 3. Oh, sorry, not 3. I saw double 3. I don't know where I got that from. Okay, notice that this is the same thing as case 1. I have a log of something equal, not the equal, to the log of something else. Those go away. So I solve. X equals 2. And all you have to do is check that in the original, this number does not create a negative here, and it doesn't. So that's my only answer. I'm done. I'm done. Let's look at the next one. I'll write it and then I'll move it. Log base 3 of x plus 6 minus log base 3 x plus 2 equals log base 3 of x. Okay, so let's check this out. I've got 2 logs on one side, so it's going to be case 3 for sure. Okay, I don't worry about what's on the right side. I'm going to condense these 2. How do I condense these 2? I have this minus in between. That means it's going to divide this on top of this. Condense it to x plus 6 over x plus 2 equals log base 3 of x. Now, I look to see if it's case A or case B. If I condense and I have a log on the other side, then it's case 1. And it is. I have 1 log and 1, and these are the same. They will always match the bases, by the way. So I cancel and I solve. I'm not going to solve because I know you can solve this. Okay, the way you would solve this is you would put this over 1, cross multiply. Okay, sometimes you will end up with a quadratic, which is the case for this one. When you end up with a quadratic, you have to set it to 0, factor, solve. If you need help with this, let me know. All right, let's do another one. So I'm just helping you out with how to start solving these. Not actually solving because I know you've got this. Log of 3x plus 2 plus log of x minus 1 equals 1. Okay, we have 2 logs on one side. You're going to condense. There's a plus in here. So that means you're going to multiply your arguments, and that equals 1. So you have log of 3x squared minus 3x plus 2x minus 2 equals 1. Okay, now this is case 3, part 2 or part B. I have condensing, but I don't have a log on the other side, so that's case 2. That means I'm going to have to do the circle, right? A circle raised to the power equal this. That's this one. So I don't know what the base is. If you have a log, the base is 10. If you see a log with no base, it's automatically a 10. That's by definition. Here. If you see a log, logs are bases of 10. LNs are bases of E. Okay, you don't have to memorize it, it's on your calculator. So then I do 10 to the 1 equals that, and the log drops. So 10 to the 1 equals, put these together, 3x squared. That's a negative x minus 2. This is a quadratic. 10 to the 1 is 10. You have to set it equal to 0. So that's 3x squared minus x. I subtract the 10, so that's 12. You factor, you solve, and you test the solutions. Okay? So here we have this function that is now set to 0. It is a quadratic. You factor, you solve, you test the solutions. Make sure that the solutions do not create negatives either in this parentheses or in this parentheses. If it creates a negative on either or, you get rid of that solution. Okay, and that's this one. So that is C. We've got, I'll do the last two, at least the setup, and then we should be good to go. Got it. Okay. D says ln of x plus ln of x squared equals 3. Check out that the left has two ln's with a plus in between. So you're going to multiply them together. So that's ln of x cubed equals 3. The next step is to figure out where it belongs. I have condensed. I do not have a log on the other side. Log or ln are the same thing. I do not have anything, so it means I have to do the circle. I do not see a base. LNs have a base of E. So I do the circle. That means it is E to the 3 equals x cubed. That relieves the ln, it disappears. Okay. I'm trying to solve for x. In order for me to solve for x, I take the cube root of both sides. This cancels, and magically this cancels too. So x equals E, which is a number. I know that looks funny. You're like, how do two letters equal to each other? They're both. Only this one's a letter. This one's an actual number. Okay. Last one. Okay. Last one, there's nothing for me to condense. It is straight. Case 1. So that means I'm going to do, sorry, not case 1, case 2. Case 2 where I have one log and nothing on the other side. So that means you're going to circle, raise, equal, lose a log. 6 to the 2 equals 2x plus 4. 36, 2x plus 4. This is not a quadratic, and you basically end up solving. You solve, and when you are done, make sure your answers do not create negatives next to the logs. That is the longest section for today. The last one we have is 6.6, which is short applications of logs, which is just one problem. Okay. What is the half-life? The half-life equation looks something like this. It is basically a decay. K is a constant, and it's given to you in the word problem. A sub 0, which is or called also A naught, is the initial amount of whatever element or property you're looking at, and A of t is the final amount. Okay, so if you're looking at some kind of example that is talking about carbon, and carbon decays 4,000 years, and the half-life of 4,000 years means that it took 4,000 years to reach half of its mass. That's what half-life is. So according to whatever problems you have, you're just going to have to plug in what they give you. For page 433, example 1. Actually, let me look it up. I'll read you the problem so that you can see where I got this from. This is the book. Okay, so let's read 433 so that you can see what it is referring to. Okay. So on page 433, it says finding the age of a fossil. Carbon-14 is a radioactive form of carbon that is found in all living plants and animals. After a plant or animal dies, the radiocarbon disintegrates. Using a technique called carbon dating, scientists determine the age of the remains by comparing the amount of carbon-14 present with the amount found in living plants and animals. The amount of carbon-14 present T years is given by the exponential function this. Let me just point it here. This one, this is the function. With K, they say that K equals, so it's more like an R, ln of 2 over 5,700. This is why this is plugged into here. Okay, that's because that's what the word problem said. The half-life of carbon-14 is about 5,700 years. If a fossil contains 1/5 of the carbon contains in a contemporary living sample, estimate its age to the nearest 1,000. Okay, so what it's asking you, if you have, I don't want to write on here. They tell you, do it this way. Okay. They tell you if the fossil contains 1/5 of the original carbon-14 contained. So 1/5 of the amount, that's 1/5 of the original amount. What is T? What is the time? Estimate its age to the nearest 1,000 years. Okay. So it means that when you're solving, this cancels that because you can only have one variable. That's 1/5 equals E to the all of this in the calculator is going to be, let's do it, negative ln of 2 equals divided by 5,700. Ooh, that gives you negative 1.2 times 10 to the negative 4. This is how it writes it. It's a really tiny number. Okay. This E is times 10 to the negative 4. All right. And then the way you solve this is the same way we've been solving these, where you take the ln of both sides, you squeeze in the ln. So ln of 1/5 equals these cancel, giving you that number, T. So in order to find the time, you just take ln of 1/5 divided by this number. There shouldn't be too many numbers. Too many word problems on the homework. All right, and that should give approximately 13,235 years when you do all that. Okay. The negative 1.2 times 10 to the negative 4 is basically this number right here. The way you would enter that, like let's say you want to enter this into the calculator, you would put ln of 1 divided by 5, close it, and then divided by this number. Now that's hard to write, so you would put negative 1.216, and now you would use the EE, which is here. This EE, which is second comma, and that would give you negative 4. That's the same number. That's what this EE, this is scientific notation. And then that would give you the 13,235. Okay. It's only one word problem, but it should be fairly easier. This one was a bit more complicated. And that ends 5, sorry, I keep saying 5, 6, 5, and 6, 6. And we are now officially done with chapter 6.